Hello and welcome. This is our first video for Chem 4410. I hope you are all well. So I have made this experiment 6. Let me give you a brief background here. So in the past, in Chem 4410, prior to us starting a research project, what we would do is spend about a week on computational chemistry doing stuff kind of like you guys did earlier this semester. And then we'd spend a second week doing things like you're going to be asked to do in this particular experiment here. The goal of this experiment is really just to acclimate you guys with WebMO, to give you an experience of using that particular software so you might have a better chance of using that software successfully to attempt to complete your research project that you guys had proposed to do, at least in terms of the computational project. As you might imagine, the laboratory project is unfortunately canceled, so there's really nothing we can do in terms of laboratory experiments at this point in the course. But at least we can have you guys do computational chemistry calculations from your very home using WebMO. One of the really interesting things about WebMO is you're really just going to build and submit calculations from your computer. We'll give you some video instruction on how to use WebMO. It's not super hard to use. The builder menu is kind of peculiar in building molecules, but other than that particular detail, I think you'll notice it's pretty similar to what we were doing with Spartan. When the calculations actually run, they'll run on the Ohio Supercomputer Center. We'll talk more about those details as we go. So this experiment here, I've thrown in some of the key conversions. Just kind of note here, this is the kJ per mole to wave number conversion, but then this is the atomic unit conversion or Hartree per particle over to kJs and kcals per mole that you might need throughout the experiment. Okay, so we're going to use this experiment to introduce you to WebMO like we were talking about. One thing I wanted to mention briefly here is that there's programs like Spartan, Gaussian Games, QChem, and others that all can be programmed to run essentially the same type of calculations using common levels of theory like Hartree-Fock, B3-Lip, MP2, and the common basis sets that we've learned about. So there's really nothing special about running these theories and basis sets on molecules with, say, Spartan. You can essentially get the same results if you were to run them with Gaussian or Games or QChem. We're going to likely use Spartan, or excuse me, Gaussian to run our calculations on WebMO, but again, we'll talk about those details later. You might be worried about points. Here's how we're going to break up the class. We're going to spend 3 of our lab periods next Tuesday and Thursday and the following Tuesday doing this particular activity here, introducing you to WebMO. Your discussion on this topic will be worth 50 points. You'll also receive 50 points for simply doing the work, either by submitting a copy of this packet once you complete it, or by inspection of your actual final report itself. Some of you guys may not have a stylus. I don't want you to stress out too much if you don't have a stylus and you have a harder time typing in or writing your results. So as you see this packet here, it's kind of like the packets we've had before. They have prompts with questions. You can essentially just use those questions and build those answers and anything you're asked to do in terms of data tables, preparing your data into your final report. If you need help, my plan at this point is actually not to use Zoom and to meet with you guys directly with Zoom at the start of class on Tuesday or even every lab period. Rather, me and the TAs will simply be available to answer your questions by email. We'll be ready and checking Carmen throughout the day if there's Carmen discussions. I think Carmen discussions are going to be good if you have a very general question, and then email or Zoom meetings if you have more specific questions. What you can do is you can set up a Zoom session if you want to email a link to me or your TAs. If you have questions, you can link your group members as well so we can meet together. We'll also have an office hour next Monday from 2 to 4. I'll be available during this time too. So we'll just be available if you have questions. This is essentially the day before you're going to have to submit your final sort of conclusion on this work for the first part of what we're going to do for the remaining 5 weeks. So let's talk a little bit about group work. So you can continue working with your group if you wish. I heard from the survey that some of you guys are going to have some scheduling issues. Some of you are in different time zones. It's not going to make it easy to meet at the usual class times. So I think the best thing I could do was come up with a lab or something you can do essentially on your own or within your group. So you'll have that choice. We're going to ask that you guys try to communicate with each other ahead of next Tuesday to try to figure out who's going to work together, who's going to stay with their group, and then we'll continue. And so there really shouldn't be much of a disadvantage if you're working alone. What you're going to see is that this experiment here essentially just has a set of calculations that a person needs to do. And then if you have a group of 3 or 4 people, then you're just going to have each of the group members do a different theory and basis set through the same calculations and then do a little bit of a comparison. So there's really not much added work if you work individually. There's not much added work even if you work in groups. You just have to do a little bit of a comparison, just kind of like make a table with all your results together and then throw a sentence or two explanation of how similar or different your results are. So I don't think, I would look at it this way. If you guys want to work together, you want to get some, interaction with your classmates still as you complete the course, keep your group together, or whoever is able to stay together, work together. And if you have to and you wish to, you're certainly free and won't be punished if you have to work separately. One thing I will mention is the conclusion is going to be written separately by everybody anyways. So each individual is going to end up writing their own conclusion at the very end of this experiment 6. So keep that in mind. So you're really not going to reduce your work by staying with your group. So in terms of writing down the road. So everyone's going to write their own conclusion anyways. So just make a decision based upon whether or not you want to keep interacting with your group members or if you kind of have some scheduling conflicts and you'd rather work at your own pace. Let's talk a bit about the final project. So this will come after the next 3 lab periods that we spend on this particular lab 6. The final project is what you guys had proposed to do before spring break. All those assignments are graded. I don't know if you've taken a look at the comments, but the computational work should able to be done. The only thing I will mention is you might, some of the groups may not have proposed to do a whole lot of computational work. So you might just try to think about, okay, we're going to need to keep ourselves busy for about 3 to 5 lab periods in terms of calculations and analysis. So again, with the final project, you can actually work individually or within groups. I actually don't mind if for some reason you guys need to switch. So if you work individually on the first 3 and then you decide after a week and a half you can actually go back to working with your group, you can change your mind. I would just say, work individually or within your group on the lab 6, and then work individually or with your group on the final project. And if you work individually, you're just going to independently be trying to accomplish the tasks that you guys have proposed to do. What I might say is if you work individually, you may just start with a simple method, maybe move into B3LIP if you have time. Again, some of the groups that propose to do a lot of work, you're just going to have to, if you work individually, pick and choose which topics you investigate and which ones you don't have time to do. But the key is just keep yourself busy for about 3 to 5 lab periods. We'll be, coming up with some ways to check in on you guys, just having you, correspond with us mostly by email. But if you need to, Zoom sessions might work as well. So let's talk a little bit about the grades for this final project. So the way we're going to look at assessing your work for the final project will be pretty simple. We're going to have participation that we judge from, if we send you emails and just say, hey, how are things going? Can you send us an email of what you've been doing and what some of your preliminary results are? If you respond to those and give us good feedback, you'll get all the points, the 50 points for participation. You may initiate some of these emails too. You might initiate some Zoom sessions. We may as well, just depending on how things go. We'll have to see how the next couple weeks go. We're going to ask you guys to prepare a video presentation. I'm not quite clear how we're going to do this, but I think there's got to be some way that you guys can make a few slides like you ordinarily would, and then just get together with the Zoom session and just kind of make a presentation on your own without anybody watching it live. And then we'll have you guys submit those to Carmen. I think we're even going to do a little peer review so that you guys might, each individually watch one of the other groups or individuals' presentations. Key here would be we're going to look at length per group member. So we're just going to want a little bit of a longer presentation for groups, and then we can, accept shorter presentations for those working individually, just to keep the workload fairly distributed. So we're just looking about 3 to 5 minutes per group member. Again, we'll talk more about the specifics of this task down the road, and then we'll have you write a written report. Both of these are going to be due at 6 p.m. on our final day of the semester, that Thursday, April 23rd. So more details to come, but that's sort of how we're going to be looking at our final part of the class. So if we look at our schedule, modified schedule here, so we're just using WebMO, maybe watching some videos. You can watch those mostly on your own time, or you can wait till Tuesday. It's going to be up to you to kind of organize. In fact, whenever you want to accomplish the work, I'm going to try to get all this up as quickly as I can, hopefully by Friday, before we begin all of this, so that you can start working promptly if you wish, or you can. I don't recommend putting it off, but I guess you could. So I'm not going to directly look for you guys to be participating on Tuesday at 9 a.m. if you're in the morning class, or at 1:15 if you're in the afternoon class. But just get together with your group. My recommendation is, if you're working with your group, you should be meeting during our normal class time, because that's a meeting time that you guys all have available in your schedules. We're going to continue that for 3 lab periods. Our due dates are going to be, like, if you notice on the previous page, they're this Tuesday, March 31st at 6 p.m. And then after that, we begin the proposal, and you'll work on that for 5 lab periods, and then you'll have a final week to put together your final report and video on your projects. Okay, so the thing that we're actually going to be doing within this particular experiment, experiment 6, the one we're spending 3 days on, is kind of comparing what makes a benzene derivative more or less stable. So we're going to look at dichlorobenzene isomers, so putting 2 chlorines in the 1,2, 1,3 versus 1,4 position. How do those stabilities compare? We're going to look also at comparing xylenes, so putting methyl groups in those positions again and kind of comparing their relative energies. And then lastly, dihydroxybenzenes. That's in a couple of pages where we talk about I don't have any pictures of them in there, but you can picture X being, or the R group being, an OH group. And with the hydroxyl group, you can have the hydrogen pointing away or opposite. So you're going to have a little bit of a conformational problem when we're investigating these dihydroxybenzene isomers. So the dihydroxybenzene isomers are the ones we look at last in this particular experiment. We introduce something, we introduced it earlier in the class, but you'll investigate the local minimum problem and then try to establish for the 1,2 and the 1,3 and the 1,4, which isomer, where do the OH groups want to point relative to each other in the most stable or lowest energy conformation. And the key here is that if you're working individually, you're probably choosing either the HF631G star if you're just interested in a fast calculation, or maybe the B3LIP 631G star if you kind of want to get some relatively accurate results. But if you have a larger group, just assign somebody to each one of these methods. As you're using WebMO, you can submit all your calculations and build them as quickly as you can, and they will run sort of in the order that they're submitted based upon how busy the supercomputer center is that day. Some days it might take an hour for your jobs to run. Sometimes they run mostly, as you're submitting them. So you might end up building your calculations on day 1, and then waiting a day for them to complete, and then going through the analysis on day 2. So again, I'll talk more about how you actually run these calculations, but you can see, there's questions and tables that you're being asked to make, some more questions and tables. And then once you get to the very end, kind of like most of our experiments had, there's this final discussion, and most of these questions here are really the questions that had been asked earlier. So you're just assembling that work into a final discussion. So again, if you don't have a stylus, don't worry about turning this packet in. You theoretically could print it, take pictures, and make PDFs. I mean, if you want to do that, that's fine. But I think if you don't have that stylus, don't stress out about turning in your work. Just, make sure your discussion includes all the data that we asked you to make, and then we'll clearly determine that you participated in the experiment, and then you get all the points for the lab participation. Okay, so I think that's it for this video. Thank you for the attention.